The next several slides describe the more technical aspects of data warehousing. We start by listing the 5 main types of DW architectures, starting with InMoN's centralized EDW, or Enterprise Data Warehouse, providing an enterprise-level structure, going all the way down to Kimball's Data Mart bus, combining departmental data marts into an enterprise system along the conformed business dimensions. In between those two approaches are a few others worth mentioning. Independent data marts are extremely valuable to individual departments, but there was a lack of coordinated company-wide effort to bring them together to the enterprise level. Federated data warehouses consist of legacy DSS/EIS systems, or decision support systems / executive information systems, and simple data marts as well, but without the overall structure. Hub and spoke approach is close to the InMoN Corporate Information Factory, or CIF, with a centralized corporate hub and department data mart spokes, so it's in a sense the hybrid approach we referenced before. The 4 major DW components are: number 1, data sources; 2, data staging; 3, data storage; and 4, information delivery. We discussed the various internal operational sources long enough by now. In addition to all of those, there is plenty of internal data in forms of spreadsheets, documents, and local departmental databases, some archive data, and then as well as external data that all must be taken into account when identifying the necessary data sources for our warehouse. The second component of any data warehouse is data staging, which is one that typically consumes the majority of resources dedicated to design and implementation of the entire system. The 3 major functions of data staging component are: 1, data extraction; 2, data transformation; and 3, data loading. Data extraction has to deal with numerous data sources, both within the company and coming from the outside. The operational systems arguably generate the majority of the data that ends up in a data warehouse, but other internal documents, spreadsheets, local databases, etc. cannot be ignored either. Procedures need to be developed to efficiently extract the necessary data from all those internal sources and supplement it with additional external data as well. There are numerous third-party ETL, or extract, transform, load tools that can be used to accomplish this, and the other 2 major data staging functions. Sometimes in-house procedures are necessary to successfully complete this stage of the process. Once all the data from all the relevant sources is extracted, it is typically staged in what is often called Operational Data Store, or ODS. ODS data is then carefully and thoroughly cleansed and transformed, standardizing data definitions, providing default values, dealing with missing values, removing duplicates and dirty values, and performing lookups to give coded data more English-like meanings. Additional transformations include combining and merging data, creating surrogate keys, which we'll talk about in the next presentation, instead of using operational primary and foreign keys that often have hidden business meanings, although the original keys are often kept as ordinary attributes, especially if their design includes industry codes or have other business interpretations. Data is also often pre-summarized at this point from higher to lower grains or granularity, and just prior to loading the data into data warehouse. Data loading follows a predefined scheduling frequency, as it's typically done on a nightly or even just weekly basis during the times of low data warehouse usage. The third component of data warehouse is the data storage itself. As we stated several times already, It is a physically separate system from the operational databases, often implemented in a relational database management system, or RDBMS, while some are purely multidimensional database management systems, or MMDBMSs, with the pre-summarized data in all-up cubes. In addition to the actual raw data, the metadata management is typically dealt with at this point. When the actual data is loaded into the warehouse, metadata, which is the data about the data, is created that precisely describes every aspect of the actual data being brought in. The typical metadata includes the names of tables, columns, the source of data, data types such as integer, double, date, time, etc., range of data values, default values, whether those are allowed or not, what, if anything, is to be done about missing values, any transformations that were performed on the data piece, and any other useful information about the data. The last component of the data warehouse is the information delivery to the business user. From regular business users that need to run few simple ad hoc queries and get the information he or she needs, to power users and business analysts who need to perform more complex queries or use more sophisticated statistical or data mining analysis, and all the way to managers and executives with their dashboards and scorecards. This is arguably what data warehousing is all about: delivery of the right information to the right business user at the right time.